Hello and welcome to BYJUs, that is Aakash plus BYJUs. I'm your friend and mentor Mrinal, and we have this wonderful offering for you, that is Aakash BYJUs Rapid Fire JEE. So we have again three wonderful participants with us who will be participating in this quiz, and with all other viewers which have joined us. Yes, I can see Parth, Mayank, Swastika, Anirudh, Sanju, Adhira. So yes, guys, we are about to start this, but before I go ahead, I want all the participants, that is who are with me, as well as those who are participating and giving their answers in the chat, all our wonderful audiences who are there, be ready with your notebook and pen, because this is a quiz on a very important topic, which is Newton's laws of motion. With that said, let's start. Okay, so yeah, we have our three wonderful participants with us: Krishna, Divyanshu, and Prateek. Hi Krishna, hi Divyanshu, hi Prateek. So I'll first want Krishna, Divyanshu, and Prateek to introduce themselves, and I'll first go with Krishna. So Krishna, can you just talk about something about yourself? In which class do you study? What are your hobbies? What do you like? And all that. Quickly, in a crisp 2-3 sentences, can you just give your introduction?
I am Krishna Gehlot from Sioni, Madhya Pradesh. I am in 11th class and I like cricket, football and kabaddi in sports, and also like sports.
Awesome. So you like studying and games both, which is a wonderful thing to do. So now over to Divyanshu. Divyanshu, can we have a small introduction?
My name is Divyanshu. I am from Chhapra, Bihar. My hobbies are reading some interesting books, playing cricket. That's all from my side.
Okay, great Divyanshu. You also like cricket. Okay, so we have got a lot of cricketers over here. All right. I don't know they are happy or not happy about Virat Kohli thing, but yeah, that's a different discussion altogether. And then we have Prateek. Prateek. Yes, Prateek, can you just quickly introduce yourself?
Myself Pratik Kese. I am from Maharashtra, Ahmednagar. My hobbies are playing chess, cricket, football, badminton, and reading books. And this much.
All right. So yes, so all three sports person here, right? Okay, great. This is great to see you guys. And it's very important to keep a balance between your studies as well as what you love. So always pursue your hobbies. Always see that you can keep a fine balance between what you have to do and what you love to do. But it's always good that you give your first priority to the studies, to the exam that you are going to give. Now, in today's session, we are going to have some really great questions of Newton's laws of motion. And I'll first go through the instruction. I hope all of you know it already. It's right there in front of your screen. So, if all three students give correct answers, then for each correct, the first one will be awarded 4 marks. The first one to answer will get 4 marks. The second one will get 3 marks, and the third one will get 2 marks. For each question, the maximum time allowed is 2 minutes, and 1 mark will be deducted for each incorrect answer. And we have got some wonderful audiences joining over here as well. We have Amar, we have Sanju, Madhulika, and Veena, Akansha. All right, hello to you guys as well. I can see each one of you placing your comments over here. Great. So if you are all ready, can I see a thumbs up in my chat so that we can start? Can I see a thumbs up from the audiences? Yeah, okay. Yes, our participants are ready. You guys are ready? Cool, then let's begin. So this is the first question. The first question of today's evening in front of your screen right now. All right. A question, a very simple one. The question says an object is in equilibrium. mark the important terms. An object is in equilibrium under 4 concurrent forces in the direction shown in the figure. Find the magnitude of F1 and F2 in newtons. You can see that at the origin, you imagine a body where there are 4 forces which are acting. 4 Newton makes an angle of 60 degree with the x-axis, and then there is F2 which makes an angle of 30 degree with the negative x-axis. So yes, the object is in equilibrium. Cool. What does that tell you? All right. Ekta, Srishti, Veena, Yogesh, Sanju, Mayank. I'm expecting answers from you guys as well. Asha, come on. Let's see who does it first. Who does it first? You have got 4 options right in front of your screen. Read the question carefully and find the magnitude of F1 and F2. F1 and F2. Think and answer. The object is in equilibrium. That gives you a very important information. Very important information, right? All right, so yes, we have got our first answer from Krishna, who thinks it is B. Divyanshu also thinks it's B. And we are just waiting for Pratik to answer. All right, so 2 people have answered it already. What about our audiences? Pratik also thinks it's B. Awesome. So all 3 of you are in unison, right? And I can see, okay, Shohit thinks it's C. Amay says it's B. Parth thinks it's A. Nawaz thinks it's V. Veena goes with B. Manjit goes with B. Mayank Raj thinks it's B. Amar thinks it's B. Sweta thinks it's B. Nawaz thinks it's B. Let's see. So most of the audiences, if I have to take an audience poll, probably it will go with you guys. Okay, but we don't know it yet, right? Who knows the answer? It's our Computer G. So Computer G, can you tell us the correct answer for this particular question? Our first question this evening. And yes, all 3 of you are absolutely correct. Wonderful job. And out of the 3 of you, Krishna is the one who has answered it first. Right, so it was a simple question based on understanding that we just have to take the components and the net force in all direction has to be equal to 0. So this was the basic idea behind this question. And for all wonderful audiences like Satyajit, Atharva, Madhulika, Amrit, Nihal, Shrishti, you guys have answered it correct, right? So you deserve all the congratulations. Well done, guys. And let's quickly look at the solutions. Okay, so as you can see, we just have to find the net summation of force in x direction has to be equal to 0. You can break it in form of components. So it will be 4 cos 60 along positive x and 4 sin 60 along y. Similarly, you can break down this F2 as well, correct? And then you can equate it to 0. Thus finding the value of F1 and F2, and the correct option is option B. Quite a simple one to start off with. All right, so let's quickly have a look at the score. So Krishna is at 4, Divyanshu is at 3, and Pratik at 2. Cool. Now time for our second question, and I'm sure all of you are ready. So second question right in front of your screen now. Second question with a diagram. Think carefully. Every word matters, and the question reads: a force F is equal to 20 Newton is applied on block A. Now block A is the bottom one, the orange one, all right? As shown, what would be the acceleration of block B after 10 seconds from the start? And in the bracket, they have given you a very important information. Assume all surfaces are smooth. All surfaces are smooth, which means there is no question of friction over here. Cool. Guys, think and answer. So yes, again, got the first answer from Krishna, who thinks it's C. Let's wait for other guys. We have Amar, who thinks it's C. We have Satyajit, Parth, Divyansh, Praveen, Madhulika, Namaz. All these guys have started answering it. Think. One block over another block. The force is on the bottom block. And they're asking you about the acceleration of the top block. Okay? After 10 seconds. So yes, the answer has come from 3 of you. Krishna feels it's C. Divyanshu thinks it's C. And Pratik thinks it's D. Let me read out the answers for our audiences also. Praveen says, sir, it's C. Okay, we'll check. Dhruv thinks it's A. And Amar thinks, okay, he has just told 0 or no friction. Yes, it's told that the surfaces are smooth. So yes, absolutely no friction. Lakshmi thinks it's C. Chaitanya thinks it's C. So most of the people are going with C, which is 0. So can we have the right answer on the screen? The correct answer. Okay, so the correct answer is 0. The correct answer is 0. Well done, Krishna, again. Well done, Divyanshu. Pratik, I think you need to understand that there was no friction. So if there was no friction, it means when you apply the force on this bottom block, it's just going to slip away, isn't it? And the acceleration of V, since there is no force on it, the only force that you can see is going to be the normal reaction and the mg. Both of them are perpendicular to the surface. Had there been a friction, then of course, if you are going into thinking of the blocks could move or could not move, will move with same acceleration or with different acceleration, all those scenarios come into picture. But over here, all surfaces are smooth. So if I have to talk about the most important line of this question, it should have been assume all surfaces are smooth. Pratik, I hope again you will take your time and make sure that you're not making such silly mistakes. All right, cool, no problem. We have a lot of questions to go ahead and I'm sure Pratik can come back strongly. Well, as far as this question is concerned, the correct option is C, and now Krishna is leading with 8 points, Divyanshu following back with 6 and Pratik at 1. But yes, surely Pratik, you can come back strongly, so be very confident when you're answering it. Every question, if you answer it wrong, will give you negative marks. Cool. So let's quickly have a look at the solution and then we'll move to the next question. So as I told you, this is how the free body diagram looks like, and as you can see, there is no net force. Or rather, I should say the net force itself is equal to 0 because N balance is mg, so there is no question of acceleration of block B. All right, no problem. Now let's go ahead to third question. Question number 3 coming on your screen right now. All right, yes, this is a diagram which we all love to see, isn't it? A wedge, an inclined plane. Angle also is something that we have seen many a times, 37 degrees. And then you have 2 blocks, all right? And then there is a force of 48 Newton. So let me just read out the question. If force F is equal to 48 Newton is acting on the system as shown, find the tension in the string. Now this string is attached between 4 kg and 6 kg block and you need to find the tension in the string. Assume all the surfaces are smooth, which means again there is no question of friction over here, and you need to take the value of g as 10 meters per second square. All right. Cool. Swastika says your chat was not working. I hope now it's working. I can read your message, Swastika. So yes, go ahead and try answering them. Option A is 12 Newton, option B is 9.6 Newtons, option C is 8.4 Newtons, and option D is 5.6 Newtons. All right. Guys, come on. Think, solve, and answer. Okay, what is the angle? The angle is 37 degrees. The angle, you're talking about the angle of the wedge, that's 37. And the angle at which the force is being applied, that angle is 60 degree with the incline. That angle is 60 degree. The force is being applied at 60 degree with the inclined plane. And the angle of this inclined plane, the bottommost angle that you can see, that is 37 degree. Cool? Shubham, I hope. Mayank, Paul, Divyanshu, Divyansh, Saurav, all these guys have started answering it already. Think about it, how you should solve these type of questions. Lakshmi, Satya, Mayank Raj, Parth, Shubham, Priyesh, Veena. I can see all these guys have started answering and plugging in the result which they feel is correct, which I cannot read out before our contestants, all three participants, have given the answers. So I cannot read out your options as of now because that's going to give them a hint probably. So I'll read out your options only when all three of them have answered. And again, Krishna is the first one to answer it and he feels it is B. Pratik also feels it's B. Pratik is the second one and Divyanshu thinks it's B. So again, we have got all three participants thinking it should be option B. And if I talk about our audiences, yes, it's a clear B. So even the audience thinks that it is option B. Okay, let's see what our computer G has to say. So what is the correct option, sir? Can we have the correct option? Yes, the correct option is option B. Well done, guys. All three of you have answered it correctly. You guys are playing really amazing. And not just playing this, but also you are learning something. That's the most important thing. That is the key takeaway from this session. Of course, playing the quiz and winning, that's one thing. That's one thing. But what you learn, what you take away, what you understand yourself, where you stand in a competition, that's an experience in itself. And yes, I would like to congratulate all those guys. Madhulika, Priyesh, Yogesh, Surya, Paul, Vishal. All of you have given correct answer and you deserve an applause for yourself. And you deserve, people should clap, not just for three participants, but you should clap for yourself as well. Yuvraj, you got it correct. Awesome. Let's quickly have a look at the solution. This was a clear-cut question, a very simple question, a very straightforward question. And in this question, what you had to think first of all is that the total mass of the system. So whenever you deal with such a scenario, what you need to think is take both of these two blocks as one system. Okay. Check the net unbalance force. What is causing the motion? Correct. So when you take the component of this force, that is 48 Newton, you find out that it is equal to 24 Newton on the entire system. But if you check the weight of the system itself, that is 60 Newtons, which means the blocks are going to go downwards. Yes, both of them are going to move downwards. What will be the acceleration? You can easily find net unbalance force, that is 60 minus 24 divided by total mass of the system. That gives you an answer of 3.6 meter per second square. And then it's all about just the application or writing down the equation of Newton's laws. Yes, awesome. And all going good. I hope you understood this, that how you need to solve any problem of this type. Always try to figure out what is causing the imbalance. All right. So which force is greater? So which direction will the motion take place? All right, cool. The correct option is option B. And as the score stands at this point of time, Krishna clearly leading with 12 points. Divyanshu is at 8 and Pratik at 4. All right, the next question. And this is question number 4. Coming on your screen, I hope our participants are ready. Our audiences are ready, right? And this time, audiences have answered it much before the participants. So guys, buckle up, come on. All right, need to do a little bit pacing up. All right, so the next question the next question, question number 4 on your screen. Question number 4. All right. Question says, a rope or a uniform rope of mass capital M and length capital L is accelerated upwards with acceleration small a by applying a force on the topmost point. What is the tension in the rope at a distance x from the lower end? What is the tension in the rope at a distance x from the lower end? Okay. Let's see. Think. Aryan is the first one to have answered in the chat. Anirudh. Then Amar, Vishal, Amay, Sneha, Satya. Awesome, guys. You guys are fabulous, I should say. We really have an amazing audience, an amazing participation for this evening. And this time, for question number 4, the first person to answer is Divyanshu, then Krishna, and then Pratik. So Krishna thinks it's B, Divyanshu thinks it's B, and Pratik thinks it's C. What about our audiences? Priyesh thinks it's B, Parth thinks it's B. I can see most of them going with option B, except for Shubham, who thinks it's C. Aryan thinks it's B. All right, awesome, guys. Let's have a look. What is the correct answer? Computer G, can you please show us the correct option? Yes, it's option B again. Awesome. So yes, Divyanshu now has answered it first. So now quickly following up with Krishna, who got it at 15. Now Divyanshu at 12. And Pratik, you need to be extra careful, boss. Little bit extra careful. Don't be in a hurry. The question was really simple. It was easy. The thing is that if generally when we deal with all these ropes or strings, we say that we are talking about idle strings, where we say that they are massless. So at any point of time for idle strings, when you deal with, you say the tension at every single point is same. That would not be the case if that rope or string has got mass, correct? Then you have to go with that mass per unit length thingy, right? Correct? Okay. So anyways, let me just tell you, if you think of cutting this string from that point where it was given, right? If you just cut it, you know, at the point where you have cut it, there will be tension, correct? One tension always acts away from the body. So if you look at the lower end of the string, it's only because of the tension which is away from the body, which is in upward direction. That is why the string is going up. As simple as that, correct? So if I think of this part which I have cut off, if I think that the mass of that part is small m, I can easily find the mass of that particular length by using mass per unit length, that is capital M by L times x. That would be the mass of the small part. Now, very simply, I'm telling you, if there is any block or anything which is going up with an acceleration, okay, vertically upwards with an acceleration of a, and then you know that the net acceleration becomes what? A plus g, correct? If it is going up, a plus g. If it is going down, then g minus a, correct? That we all know, isn't it? And then if it starts falling down with the same value of acceleration, which is a case of free fall, then you know that the value becomes equal to 0, and that we call it as a state of weightlessness, isn't it? Correct? Okay. So yes, if you would have thought on that grounds, you would have got it exactly correct. Okay. So yes, can we just have the solution on the screen? Okay, so yes, this is what I was talking about. So you think about that part, why is it going up? Why is it going up? It's only going up because it is attached to the upper part. And what is the upper part doing? There's a tension downward, and for the bottom part, there is a tension upwards. Cool, okay? And then it was all about writing down the equation of Newton's law, right? So T minus mg is equal to ma. So T is equal to m times of g plus a, correct? And then the value of small mass was equal to m by L times x, and the acceleration g plus a. So that would have been the correct option, which is option B. Okay, Harinivas, thank you so much. Thank you so much. If you are understanding, that's great. But yes, make sure that you are answering the questions correctly. Okay. Okay. Cool. Fine. The scorecard reads Krishna at 15. Divyanshu quickly covering up the gap at 12. Prateek, yes, you need to be focused. You cannot afford to do any more mistakes now. All right, because we have a small segment only. So if you're making more mistakes, you get behind and it's difficult then to cope up. All right, the next question, question number 5. If everyone is ready, question number 5 on your screen right now. Yes, again, a very interesting one. Read the question very carefully. The question says, n number of equal masses are connected by strings of negligible mass as shown. The tension in the string connected to nth mass is. Okay? Excuse me. Okay? What is the tension in the string connected to nth mass? The last mass which is kept on the table. Yes, we have answers coming up. Divyanshu is the first one to answer and he feels it's A. Krishna also feels it's A and Prateek also feels it's A. All right, all right. Awesome. And if I look at the chats, A seems to be a clear winner. Okay, Vishal and Shuyash, Priyesh. We have Dakshin, Om Prakash, Lakshmi, Amar, Shubham. The entire audience is of the opinion that the correct answer is option A. So yes, Computer Ji, can we have the right option on the screen, please? Yes, that's right. Option A is correct. All right. So again, Divyanshu is the first one to answer and quickly closing in. Now the difference is only of 2 marks. And Prateek, you got it right. So well done. Good job. Now the idea is, in this case, think, what is the force which is trying to pull it down? What is the force which is trying to pull it down? It's obviously capital MG, right? Isn't it? So if you think of the entire block on the system, first thing is that you will think of finding the acceleration. So net unbalanced force is capital Mg divided by total mass of the system, which is n times small m plus capital M, correct? And then once you have got the acceleration, you know that the entire system is moving because of that reason. And we know that the tension is different for different blocks. But if I think about the last block is only moving under this acceleration because of tension. Because if you think about any other block, there will be 2 tensions. One will be pulling it in one direction, another one will be pulling it in other direction. But if you think about the last block, correct, and that is what was asked, the last block is moving only because of one force, which is tension, which is along the direction of the acceleration, obviously. So what we get, T is equal to mass times of acceleration. Acceleration, you have found it. So you get the correct option as option A, which is the correct choice, the right answer. And obviously all 3 of you have got it correct. Okay. Is there some technical difficulty? Okay. So is it paused or shall we continue? Okay. So yeah, I think there's some technical difficulty going on, but I can see Vishal and Aditya and Gaurav. Yeah, good to see you too. Mayank. Okay. Shubham. No, it's not over, Shubham. Don't worry. We'll be quickly back. All right, we are trying to get all the three participants back online as soon as possible. All right, there's been some technical glitch. I suppose, how can I get selected in this round? So see, every Friday, the forms are rolled out. Make sure that you fill up the forms and you could be one of those participants who will be here on this platform talking to your favorite teachers and participating in this quiz. Okay. Okay, and we have Suvangi, we have Sneha. Sir, how can I join the quiz? I told you every Friday the forms are rolled out, guys. If you are interested, make sure you fill those forms. Okay, and then probably because we get many entries, we have to select 3 of them. So if you're lucky enough, then you get a chance to be with us on this quiz, and it will keep on going, and definitely you're going to get a chance for sure. Okay, yes, Shubham is saying I'm also a BYJU student. Good to know that. Sir, I'm in 11th. I can join. Yes, definitely. Vishal is saying, sir, syllabus तो 70-80% हो गया है, पर mock में 120-140 ही आ रहे हैं. See, Vishal, it's very simple. अभी 70-80% सिलेबस हो गया, अभी आपने सिर्फ एक बार पढ़ाई की है, राइट? सो जब आप धीरे धीरे और इसको रिवाइज करेंगे, डेफिनेटली इट्स गोइंग टू इम्प्रूव. सो अंडरस्टैंड कि कहाँ पे आपसे गलतियां हो रही हैं, कहाँ पे आप ऐसे मार्क्स आपसे छूट जा रहे हैं, और उन जगहों पे या उन टॉपिक्स को आप एक बार फिर से रिवाइज कर लीजिए. ऑलराइट, सो वी हैव गॉट ऑल द पार्टिसिपेंट्स बैक ऑनलाइन. ऑल गुड. सो नाउ मूविंग टू आवर नेक्स्ट क्वेश्चन. इज एवरीवन रेडी? Is everyone ready? Okay. Question number 6. Coming up on your screen right now. Question number 6. All right. The question is, a body of mass 1 kilogram is moving with a velocity of v is equal to 10 I cap plus 5 j cap meters per second. Of course, v is a vector. What is the angle made by the momentum vector with the x-axis? What is the angle made by the momentum vector with the x-axis? Let's see. Krishna has answered it already. Awesome. He feels it's option C. Amar, Satyajit, Swastika. We have Suhani, Sneha. Wow. You guys are really fast, isn't it? Okay, this was pretty simple. I totally agree. Yes, this was a simple question. Of course, we know that in this case, the angle of the momentum, it's very simple. Momentum is mass times velocity, correct? So, whatever is the direction that this velocity vector is taking, the momentum will also be in the same direction. So, it was all about finding the value of tan theta, which will be the y component by the x component, the magnitude wise I'm talking about, correct? So it's pretty simple. And now let's see the correct answer. The correct answer, yes, the correct answer is option C, which all 3 of you have answered obviously correctly, right? A very simple question, and I can see in the chats as well, all my wonderful students have answered it correct. Lakshmi, Mr. Music, okay, and Swastika has gone ahead and even explained the answer. Wonderful job. Amar, all of you have answered it at option C. Option C is absolutely correct for this particular question. So well done, good job. So now the score stands at Krishna 22, Divyanshu 18. It's just one question. All it takes for Divyanshu to go ahead of Krishna. And the best part is that you guys have been answering all questions till now correctly. Pratik at 8, but I'm sure that he can buckle up and he can recatch. Cool. Let's go ahead to the next question. Question number 7 on your screen right now. Okay. The question says, a body of mass 6 kilogram is at a distance of 16 meters from the pulley at t is equal to 0. When it is released, as shown, if the string is cut after 2 seconds, then find the time after which the 6 kg block will hit the pulley. Consider the surfaces to be smooth. All right. All right, guys. I have a request to the audience. This is question number 7. So when you're placing your answers, please write question number 7, because that makes me confused about your answers, because the chat is going really fast. So I cannot understand if you're answering for the previous question or this question. So please write question number 7 and whichever option you think is correct. Okay. The first answer coming from Krishna, that's option C. Divyanshu comes in second. He thinks also it's option C. And Pratik also thinks it's option C. Now, if I talk about this particular question, you need to understand that the most important word of this question was when it is released. So whenever you look at a question and when you see this term, when it is released, it gives you a very important information. And that information is that initially the system was at rest. That's the most important information. That's the most important takeaway. All right. So the whole idea is to find the acceleration, correct? So what is the net unbalanced force? Why will the system move? First of all, because of this 4 kg mass. Because on this 4 kg, there will be a force of gravity. How much? 4g. That is 4 times of 10, correct? So because of that, it is going to move. So how do we find the acceleration? Net unbalanced force divided by the total mass of the system. Once you have got the acceleration, then it's very simple. Because the string is cut after 2 seconds, which means the force vanishes after 2 seconds. So the acceleration will become 0 after 2 seconds, correct? Which means till 2 seconds it is going to be an accelerated motion, and after 2 seconds what will happen is that it is going to move with a constant value of velocity. So if you find that out, you understand that in first 2 seconds this block, that is 6 kg block, would have traveled 8 meters. And at that point, after 2 seconds, the velocity of this 6 kg block would be 8 meters per second, which means it is going to take 1 more second before it hits the pulley, which was initially at a distance of 16 meters from this block. So the total amount of time that it took for the 6 kg block to hit the pulley would be 2 seconds plus 1 second, which is going to be 3 seconds. Yes, so computer ji, can we have the correct answer? I've already told the correct answer, but yes, all 3 of you have answered it correctly. The correct answer is option C. So good job, well done, and well done, my dear audiences as well. I can see Anandita. Option C, yes, Anandita, I have seen your answer. Mr. Music has got it right as well. Suhani has got it right as well, and most of you guys have got it right. Awesome. So, well, that makes Krishna at 26, Divyanshu at 21, and Pratik at 10 after 7 questions. Are you ready for the next question? Yes. But before I go on to the next question, I would just have I just want the students to have a look at the solution. I don't want to explain the solution. I want you to have a look and see for yourself how it was supposed to be solved. Sorry. I hope the things are clear now. Yes, Praveen, I know you told that it is C and the correct answer is C. All right. Now, before going ahead, I just want to ask our participants, Krishna, how are you feeling? Leading at 26.
I am feeling good.
Great. Divyanshu, क्या जल्दी से पीछा करना है, right?
Yes, sir. Yes, sir.
Good, good. Pratik, initially थोड़े problems हुए, but now you are back, I think, isn't it?
Yes, sir.
Okay. Awesome. So, just want to know from the audiences, who are they supporting? Who do you think is going to win? Because we are almost halfway through. So can I know? Can I see the supporters over here? Yeah, guys, can I see? You have the scorecard in front of you. So yes, let's show some support. Come on. Okay, we have some supporters for Pratik, Krishna, Divyanshu. People are saying all are equal. Some are saying, sir, kuch nahi keh sakte hain. Okay, all right. Awesome, good going, good going. Yeah. People, most of them, Lakshmi, Abhay, Amar feels Krishna. Okay, good. Let's see the second half of the quiz. And now the questions are also going to be slightly on the trickier side. So I want you all to be extra cautious while solving it, and not just our 3 wonderful participants, but also the audiences. Okay, cool. Now the next question, question number 8. on your screen right now. Look at the question. The question says, for a system as shown, find the tension in the string. If the system is in equilibrium. If the system is in equilibrium. Think question based on pulley constraints. Okay. Question number 8. Divyanshu is the first one to answer. Then comes Krishna, who feels it's C. And then Pratik, who also thinks it's C. What about our audiences? Yeah, if I can say, C would be a clear winner. Alright. I can say all our audiences are also winners. Because I have seen most of them answering correctly till now. Not even one single question they have answered it wrong. Some of them I can say for sure. Alright, so Vishal thinks it's C. And Suhani also thinks it's C. Amay thinks it's C. Great. Sankalp thinks it's C. Alright, let's look at the question. Okay, so if you think about this block M, it is being supported on one side by one string, which is T. And if you look at another block or the other pulley, which is a single movable pulley, so TT, the T dash is going to be equal to 2T. So the net support it has is equal to 3T of obviously, right? Okay, so which option is the correct one? I've almost told the answer. Yes, and you know which option is going to be right. For this particular question, the correct option is option C for sure. Yes, that's right, and you guys have done it again. Again, we have Divyanshu who has answered it correctly. Okay, so bridging the gap. Pratik also answered it correctly. Well done. Krishna answered it correctly. All three of you have answered it correctly. And not just that, all our audiences, all of them have answered it correctly. So great going. What I can say, we are having a fabulous evening this time. Okay. So let's quickly look at the solution. Quickly, the solution is very simple, straightforward question. All right, on pulley constraints and not much to think about. Okay, let's have a look at the scoreboard. We have Krishna 29, Divyanshu 25, and Pratik at 12. Okay. Yes. Moving on to our next problem. Next question. Question number 9 on your screen right now. Question number 9. What is the minimum value of F needed so that the block begins to move upwards on frictionless inclined plane as shown? There's a force, as you can see, and the angle that this string is making with the inclined plane, okay, is theta, as you can see in the figure. Question number 9. Divyanshu is the first one to answer, and he thinks it's option B. We have Aryan, Shashwat, Ashish, Surinder, Anushka, Ashish. I've seen your answer, Ashish. No problem. Nitesh, Sneha. What about our participants? All three of them have answered and all of them think it's B. What about the audience? Except for Aryan and Ankush, most of them are going with option B. Vishal thinks it's C. Okay. Awesome. Great job. Let's see. Computer G, can we have the right answer on the screen, please? Yes, that's right. Okay. Option A is the correct one. Yes. Okay. This time. Understand. Because most of our students, even in the chat, have got it wrong. And, well, you don't have to be too much worried because all of you have got it wrong this time. The reason is, think this F will have a component. that is going to be F cos theta. Plus there is a string on the other side as well, isn't it? So the net tension that you're going to experience is going to be F plus F cos theta. And that you have to counterbalance with mg sine theta, which will be the component of the weight along the inclined plane, isn't it? Correct? Okay. So see, if I would have just kept the string directly like along the inclined plane only, then you could have written that, okay, t this side, so 2t. That's true. Correct? If that side is F, this side is F, then t is equal to 2F. Yes, that could have been the case. But over here, you need to take the component, which is very, very important. All right. So yes, I'm sure that you guys must have realized your mistake. Correct? Okay. And we had Mr. Music who answered it correctly. And we had a couple of students as well who answered it correctly. But most of them got it wrong. So can we have a look at the solution, please? So if you look at the solution, F plus F cos theta, as I told you, will balance the component of weight along the inclined plane, which you know already is going to be mg sine theta. And then it was all a game of trigonometry, right? Okay. Okay. So I hope you have learned that where you could go wrong. All right. So such a simple question, but yes, I know that the scoreboard is not going to change so much as all of you have lost 1 marks each. Okay. Had anyone answered this one correctly, the tables would have turned. Yes, that's what I tell you. All it takes is one question. One question. All right, but great job. Okay, Vishal, same method but silly mistake. Koi baat nahi, Vishal. It's okay. Okay, all right. Sahil is asking, winner को reward मिलता है sir? हाँ बिल्कुल मिलता है, reward मिलता है, but सबसे बड़ा reward है the learning experience that you take away. All right, the biggest reward that you can get is what you are learning right now and how to solve questions right now. So you're revising as well as playing as well as winning. All right, okay. So the next question, time for our question number 10. So question number 10 on your screen right now. Be careful, guys. Understand, think, take a moment and then solve. The question is, what is the ratio of the readings by the spring balance A and D at equilibrium? A and D. If you can see, there are two tiers. The first spring balance, the first tier is A, and the first one in the second tier is D. Okay? Which option do you think is correct? Question number 10. Divyanshu thinks it's A. Krishna also feels it's A. Okay, and what about our audiences? Budh thinks it's A. Kuldeep thinks it's C. Ashish thinks it's A. Vishal thinks it's A. Vishal Agrawal thinks it's C. Nikhil Chauhan thinks it's A. Awesome. Xavier thinks it's C. So we have a kind of a fight going on between A and C. But if I look at our participants, they are more inclined towards A. I would say you need to think a little bit more before answering. All three of you, all three of our participants, think a little bit more. This is an equilibrium situation, right? Which means in the top tier, all the three tensions, if I can replace them with just tensions, will be balancing the entire weight. So one is going to show you that weight, correct? Okay. And if I talk about, so 1/3 of the weight rather, think of, or if I can just replace them with strings, what would have happened? Just think in that terms. All right. Okay. Anyways, the correct answer for this question, sir. The correct answer for this question. Computer G, can we have the right option on our screen? It's option C. It's option C. Okay. Yes, I can see some of our audiences have answered it correctly. Swastika, Sanjesh, Suhani, Mr. Music, Shubham Kumar. Awesome, guys. Good job. Okay, you have got it. What our participants have missed it this time. Just imagine that you replace them with 3 strings. So if you look at the first tier, the entire weight is being balanced by 3 strings. So T plus T plus T, which means 3T should be equal to mg. What does that tell you? That each one of them is going to show a weight of mg by 3. Correct? If I talk about this second tier, you can see that there are 2 springs. I can replace them with strings because it's an equilibrium condition, of course, so I don't have to worry about what would have happened or how much is the elongation and all that. Nothing to worry about that. You can see the spring constant is also same, and that is the specific reason why they have given you like this. So 2 strings are balancing this mass. So what I can say, 2T is equal to mg, correct? So if you look at the reading, on one of them it's going to show half and half, correct? Okay, so certainly the ratio is going to be 2:3. Let's have a look at the solution. I'm sure now you'll get it. Isn't this very simple? Yes, guys. Okay, but however, since all of you got it wrong, the scoreboard technically remains the same. All right, great job. Yes, if the spring constant would have been different, this would have been altogether a different question. But they have asked you a question which is supposed to be solved in 1 minute or less than 1 minute's time, which happens in case of your JEE Mains exam. में आपको ऐसे ही questions मिलेंगे और ऐसे ही examiner आपको फंसाएंगे. All right, I hope you guys realized your mistake. आपको समझ में आ गई बात कि आपको कैसे इस टाइप के questions को tackle करना था. And I hope from the 3 participants that you're not going to repeat these kinds of silly mistakes. However, we got some of our audiences who have got it absolutely correct. So, well done to those guys. Great job, great going. At this point of time, the scoreboard stands as Krishna at 27, Divyanshu 23. So Divyanshu, you had 2 choices, I should say, or 2 times you had an option of leading. Yeah, so just be careful. It's just 1 chance. All it takes to overshoot Krishna, or probably just come in neck to neck with Krishna. And Krishna, you need to be very careful now. 1 mistake and Divyanshu get 1 right and you lose your top position. All right, so all this hard work to maintain your top spot from the starting can go down. All right, yes, Pratik, you have been doing well, but had you answered these 2 questions correctly, I'm sure you would have shot up and you would have been there. So every question is very important, guys. Think before plugging in your answer. Think twice before plugging in your answer. With that said, let's quickly go on to our question number 11. Question number 11. Okay, a question on constraint motion. One of my favorite topics. Okay, constraint motion, wedge constraint. Find the acceleration of B. B is the top one. If the acceleration of A is 4 meters per second square, and if B is allowed to move only in vertical direction. You have got 4 options. Think and solve. It's a constrained motion. So this block B has no other option, but it can have only a vertical acceleration. Okay, and you have this inclined plane, the wedge, going horizontally at an acceleration of 4 meters per second square. Think and answer. So Krishna thinks it's option B. Divyanshu thinks it's option C. Okay. Let's see what our audiences are thinking. By the time Pratik is answering, we have Samir, Anand, Sheila, Suhani. All of them thinks it should be option C. But Anand thinks it's option B. Anand, you need to just tell me which option do you think correctly. You are putting in all the options. All right, A, B, C, and D. That cannot be correct, okay? All right, this is cheating, guys. Don't do that, okay? So, Mr. Music thinks it's C. I have no other option but to name you like that because that's the name of your channel. Anyways, Deepak Kumar thinks it's C. Sneha Anand thinks it's B. Let's check. Computer G, can we have the correct option on the screen? All right, option B is correct. That makes Krishna answering this question correctly. And Divyanshu and Prateek. Okay, you missed it, boys, this time. I think slightly. Okay, let me tell you how to deal with situations like these. Whenever you are dealing with this kind of a scenario, wherein it's a wedge constraint, understand that the contact is not going to break, right? The contact is not going to break. The contact is not going to break. Then what you need to think is that the component of acceleration along the normal has to be same, isn't it? If along the normal the component of acceleration is different, then the contact is going to break, correct? The constraint is that they must stick together, isn't it? Correct? So all you have to think is draw the line of normal, which certainly will be perpendicular to this inclined plane, and along that direction you have to break the components of acceleration and equate them. So if you break them, what you get is A sine theta is equal to AB cos theta. Okay, so from there itself you could say that okay, AB is equal to AA tan theta. Just plug in the value of tan theta and you get it there. Okay, all right, I hope you got the idea. Okay, so the correct option is option B, and I'm sure the audiences who have answered it correctly, Xavier, Vishal, Amar, and Suhani, I hope you got where you went wrong. Yes, this was a question of constrained motion. All right, cool. Now, so I'm sure you guys are learning. One thing is that you are solving the questions. Another thing is you're also getting an idea about where you can go wrong. Okay, so this type of a quiz can also be thought as a simulated environment for your actual exam where you're competing with your competitors. All right, so you understand that wherein you're going wrong, the speed, the accuracy, where you're making mistake, and how you should think about some typical questions. Let's go ahead, guys. Let's go ahead. Next question. Question number 12 on your screen right now. Next question, question number 12 on your screen. The question says, for a system as shown, find the displacement of block A in x-axis. Just, you have to find the displacement of block A in which direction? In x-axis in the time interval of 3 seconds. Okay, assume the string is massless and inextensible. Deepak is asking, sir, how to participate? Deepak, I've told it before also, I'll repeat it again. The forms will be rolled out on Fridays. You need to make sure that you fill the form of participation, and then you could be one of the selected ones who get a chance to be here with me and play this quiz. All right, Krishna is the first one to answer and he thinks it's option C. Divyanshu also thinks it's option C. Okay, we have got audiences. Roshan thinks it's D. Lakshmi thinks it's C. Veena thinks it's C. Swastika thinks it's C. Buddh thinks it's C. Vishal also thinks it's C, which means if I go with a voting pattern, when people are voting for it, certainly C is the winner. But we have to see, this is not an election, it's a question, isn't it? We need to see, it does not go with the common notion or the idea. All right, now that is making you confused, isn't it? But okay, I'll tell you. The question is very simple. The most important line of this question, and see how you should read it. That is what I was talking about. The most important line of the question was that along x direction is what you have to find, isn't it? Along x direction. So that's the key word. All right. A very simple question. Now you should understand that it's connected by one single string. So whatever is the velocity of B, the same velocity along the string will be for A, correct? Which means that the velocity of block A is also going to be 5 meters per second. If that be not the case, then they will separate out, obviously, isn't it? They're moving together. Now, if you want to find the component of the velocity along x direction, you know the component of the velocity or the velocity along this rope or the string is 5 meters per second. And the angle that it makes with the horizontal x-axis is going to be 37 degrees, isn't it? Because that's what it makes with the angle with the horizontal, block A, correct? On the block A side, you can see the angle 37. Which means the component will be what? What? You have to take the component of 5 cos 37, correct? So now you have got the velocity, time is given to you. It's a very simple question. So which option is correct? Computer G, can we have the right option on the screen? All right, option C is correct. And the first one to answer is Krishna, who is racing ahead now. The difference now stands for 10 points. 10 points. Okay, so Krishna now leading ahead. And we have got many of our students who have answered it correctly. Soumya, Sachin, Mukund thought it was D. Now I hope, Mukund, you would have understood that where you could go wrong. Okay, Sachin thinks it's C. Priyanshi, great job. Okay, this one was easy. Yes, it was. But the keyword was along the x-axis. All right. So anyways, time for our next question. Before that, let's quickly have a look at the scoreboard. Krishna stands at 35, Divyanshu at 25, and Prateek is at 11. Let's go ahead. The next question coming on your screen. Question number 13, this question. Question says, what should be the acceleration A of the box as shown so that the block of mass small m exerts a force F is equal to mg by 4 on the floor of the box. G is the acceleration due to gravity. G is the acceleration due to gravity. Got 4 options. Krishna thinks it's A. Divyanshu is the second one to answer. He also feels it's A. And we have got Mukund, Vishal, Mr. Music, Yogesh. All these guys have started answering. And all 3 participants have answered it as option A. Correct. Now, as you know, when it is going down, okay, I've just told you that whenever you deal with vertical accelerations, what formula you need to apply, correct? So can we have the right option on the screen, please? Yes, that's option A, which is correct. And I can tell you all of our audiences have got it absolutely correct. All right. 2 ways to do it. One is you think of the pseudo force situation, because obviously if you sit inside this box, you will be in an accelerated frame of reference. Otherwise, simple thing, just remember this as a trick. Okay, when it comes to the vertical motion, if the body is going down, net acceleration G minus A. It's going up, G plus A. All right, okay. So I just told you that how you can quickly remember it and tackle question like this. So with that said, I'm sure all 3 of you have got it correct, which means Krishna got, and Krishna is the first one I think to answer. So Krishna is at 39, Divyanshu at 28, and Prateek at 13. Okay, let's go to the next question, the penultimate question of today's evening. The next question. Next question, please, on the screen. The question says, a block of mass small m is placed on the floor of a lift, which is moving with a velocity v equals to 4t squared, where t is the time in second and velocity in meters per second. find the time at which the normal force on the block is 3 times of its weight. Now instead of acceleration, which we are so used to, velocity is given as a function of time. The only hint that I can probably give you is how to get to acceleration from velocity. Think, if velocity is varying, then how do you get to acceleration? And then it's all about looking at the motion. Is it going up or vertically down? Correct? Okay. So yes, we have Divyanshu, first one to answer this, and he thinks it's option A. Then comes Krishna, then comes Prateek, and all three of you feel that option A is the correct one. And if I talk about our wonderful audiences, yes, Yash thinks it's A, Roshan thinks it's A, Swastika thinks it's B, Sneha thinks it's A. Most of the audiences are going with option A. So yes, Computer Ji, can we have the correct answer on the screen, please? The correct answer is option B. So the main thing was to first find the acceleration. You had to first find the acceleration. Correct? Okay. Again, we have lost connection with one of the participants. We are trying to reconnect quickly. In the meantime, let me just talk to our wonderful people over here. Vishal, Karthik, Nitesh, 007. Wow. Okay. Dream Big, Suhani, Anuj. So now I think if you have made a mistake, you would have understood that where you can go wrong. And these things are very important. Kavita, hello, good evening. Good evening. Okay. I hope the audiences are also enjoying it. Soria, hi. Hello. Can I get some response from our wonderful audiences today's evening? I hope you guys love this kind of a quiz, isn't it? And I'm sure you all are eager to participate in this type of quiz from our platform. So all you have to do is that the forms will be rolled out on Friday. You need to make sure that you're filling those forms, and then probably you will be selected. Okay. Hi guys, hi, I know. I can see all of you, but I hope you all are enjoying it. If you're enjoying this, can I just get a thumbs up from your side? And can I see all those who have got it correct, all the correct answers today's evening? Okay, can I have your responses in the chat, please? Swastika is asking, how many questions are left, sir? Just probably a last one. Just trying to get in touch with one of our participants. We just lost the connection with them. So they'll be back soon. In the meantime, we can talk over here. Hello, good evening. I hope you guys are preparing for your exam really well. You have started off with your revision, whether you are in 11th standard or 12th standard. Plus, make sure that you always do every question, every problem with the time. Time is going to be the key factor in deciding. Certainly going to be a key factor when it comes to deciding on your rank. All right. So yeah, I think now we are back online with our 3 participants. Okay. So I think we have lost connection with Prateek. Okay. Because of the time constraint, let's quickly continue with Krishna and Divyanshu. Anyways, at this point of time, I don't think Prateek had any chance to come back into the game. So the last couple of questions which is left. Anyways, can we have the last question on the screen one more time, please? Okay. So this question, a 10-kilogram monkey is climbing a massless rope attached to 15 kg mass over a smooth pulley. The mass is lying on the ground. Okay, I think we are We have again lost connection. There are some technical difficulties that we are experiencing. I'm really sorry for that. Our team is on it and they will get back to it soon. It's just the last question, one question which is left, just one last question. So just be there, guys. Yes, Vishal is saying it's HCV. Whenever a question of a monkey comes up, people quickly relate it to HCV. Yes, it's somewhat a related question, okay? But yes, it's more important that you should solve it. The question is that a 10-kilogram monkey is climbing a massless rope attached to a 15 kg mass over a smooth pulley. The mass is lying on the ground. In order to raise the mass from the ground, he must climb with an acceleration greater than. And you have got 4 options. Option A says 5 meters per second square. Option B says 2.5 meters per second square. Option C says 2 meters per second square. And option D says 10 meters per second square. Think and answer. Last question of today's evening. You all must get it correct. Come on. Think about it. Think about it. So we are getting responses. Krishna is the first one to respond and he feels option C. And Divyanshu feels it's option A. If I look at the audiences, yes, there is a kind of a fight which is going on between A and C. Manas thinks it's A. And we have Amar who thinks it's C. Arpit who thinks it's C. Alright. Sneha feels it's A. Bilal feels it's B. Okay, we have got one person who thinks it's B as well. Let's see. So can we have the right answer on the screen? Alright, the correct answer is option A. So yes, Divyanshu, you got it right this time. Okay, so the gap is narrowed down, but had you answered one question correctly, I'm sure that you could have got way closer to Krishna. But yes, if I talk about our wonderful audiences, Jai Kishan, Madhvendra, Vishal, Chittu Kumar, Meeran, Manas Duvedi, all these guys have got it correct. All right. So, can we have a solution of this problem? You see, how do you deal with such situations? Very simple. Think about the monkey. The monkey is trying to pull the rope downwards, right? As he tries to climb up, which means for the monkey, what we can write? T minus mg is equal to mass times of acceleration. Correct? If he's climbing, then I can write from this equation itself T is equal to 10, which is the mass of the monkey, times g plus a. Okay, he has to raise what? A 15 kg mass. So can I say that 10 times of g plus 10 times of a must be greater than 15 times of g? Obvious, isn't it? And that gives you an option A should be greater than 5 meters per second square. Alright, with that said, this brings us to the end of our today's session. And I can certainly congratulate Krishna, who has won this rapid fire JEE today's round with 37 points. But let's not forget Divyanshu, who has played really well, and had it been just one more question or a couple of more questions where he could have done it little better, I could say, and probably the tables might have turned, we never know, but he really gave a tough fight to Krishna. Prateek, yes, he was playing really well, but we lost him in the middle. The correct connection got lost and we could not get back to him. So anyways, as far as the today's situation stands, Krishna is the winner of this quiz, but Divyanshu and all our wonderful audiences are winners as well. Everyone is a winner, correct? So you all have won some knowledge. You all have learned something, and that's the most important thing to take away. And I hope that all our audiences have really enjoyed this session as well, being participative over here. And I can say that we got the most of reactions from our audiences today. So let me congratulate Krishna. Well done, good job. And also Divyanshu, you have also done really well. All right, so with that, let's bring it to a closer. This is your friend and mentor Mrinal. I'll see you again. Keep learning, keep thinking.